So our video for today is about 2.7 day 1, and we're going to start talking about a new form for linear equations called point-slope form. So the goal for today is to identify some equations that are written in point-slope form. We're going to write equations of lines using point-slope form, given a variety of things, points, slope, and or graphs. And then we're going to graph lines that have equations given in point-slope form. So we're really going to get the basics of point-slope form down today. So before we get into that, though, our warm-up is a little review of some things that you did for quite a while before the quiz. So this one says, write the equation of the line in slope-intercept form, regular old slope-intercept form, that goes through the points -3, -4, and -5, -8. So if you haven't tried this warm-up yet, go ahead and pause the video and take a shot at it. So slope-intercept form, this is our first big deal, right? Slope-intercept form is y equals mx plus b. So if I am going to write my equation in slope-intercept form, that means I need to find my slope, and it means I need to find my y-intercept. And right now, it doesn't look like I have either one of those. So I'm going to start by finding my slope. Now remember, the slope formula is y2 minus y1, or I'm going to subtract my y's, over x2 minus x1. I'm going to subtract my x's. And whichever y value I pick to go first on the top, I have to have that x value go first on the bottom. So let's call this, we're going to call this y2, and this will be y1. So it'll be -8 minus -4. Watch your negatives here. And this is part of the reason why we have this as the warm-up. All right. And then we're going to say -5 is x2 and -3 is x1. So I'll have -5 minus -3. All right, so now my two negatives turn to a positive at the top, so I have -8 plus 4 gives me -4. And I have two negatives turn to a positive on the bottom, and I have -5 plus 3, which gives me -2. Now when I'm simplifying that fraction, again, two negatives turn to a positive, so I get positive 2 over 1, or just positive 2. So my slope is 2. Now, if I was going to write this in slope-intercept form, I still need to find b, right? So far in my list of y, m, x, and b, I just found m. M was 2. I don't know b. B is still a question mark. But I do have an x and a y, right? Now you could use either one. But I'm going to go ahead and say, let's use -3, -4. So x would be -3, y would be -4. So if I plug in to y equals mx plus b, using the point and the slope that I have right there, I would have -4 equals 2 times -3 plus b. So since I have to solve for b, I'm going to do this other stuff here. So let's see, that means I have -4 equals -6. 2 times -3 is -6 plus b. I'm going to add 6 to both sides. So I ran out of room here. So I get b equals positive 2. So now I have my slope, I have my m, I have my b, so I can write my equation of my line, which would be y equals 2x plus 2. So big thing to take away from this was, watching those negatives when we plug into the right spots, and then knowing what I'm looking for to plug into my slope-intercept form. But also saying, wow, that is a lot of work, kind of, right? To find the equation of a line when I'm given 2 points like that. Maybe there is a form that wouldn't be so much work when I'm given certain situations. And that's what we're going to get into today. So that is called point-slope form. So slope-intercept form was y equals mx plus b, right? y equals mx plus b, where m and b are placeholders. The x and the y stay in the equation, right? So m and b are placeholders for those numbers that will tell you what line you're talking about. So here in point slope form, this one's more complicated because there's different things that we need to have placeholders for. So point slope form is y minus y1 equals m parentheses x minus x1. Now, just like m and b were placeholders, we have some placeholders here. For example, I have m. What do you suppose m stands for? Same thing as in slope-intercept form. M stands for slope. But then instead of b, I have this y1 and this x1. Now, hopefully, you have, after your slope formula, this looks a little familiar to you, right? So x1 comma y1 is really the coordinates of any point on the line. Notice it's any point on the line. When I have slope-intercept form, I have to use the y-intercept. There's only one of those, and you have to find it in order to write the equation of the line in slope-intercept form. With point slope form, you have to know the slope, but then you can use any point at all on the line to write the equation. So the good news here is you have a lot more options to write that equation, which means it usually goes a little faster. The problem is there are many possible answers for the same line. So that makes it a little confusing. And also, the equation's a little bit more complicated than slope-intercept form. So in general, we use slope-intercept form more than point-slope form, but sometimes point-slope form really comes in handy. So we're going to really focus on writing things in point-slope form today. So m is the slope. x1, y1 is any point on the line. That plane y and the plane x stay put. They're part of your equation, just like in slope-intercept form. All right, so for our first problem here, I just kept that slope-intercept form right up there in the top right corner for you, just so that you have it to glance back on. Here we're going to try and write the equation of the line in point-slope form. If we're given that the slope is -3, and it has to go through the point -1, 5. So I'm just trying to fill those places, right? I'm trying to fill m with whatever the slope is. Oh, here, the slope is going to be -3. That's going to be m. And I'm trying to fill the spots for x1 and y1 with my point. Oh, it says that it goes through this point. So -1 would be x1. And 5 would be y1. Now be careful, right? Just watch your order here. So if I'm going to write the equation here, it would say y minus, now I need y1. y1 was 5. Equals m, instead of m, I have my slope is -3. Then I have parentheses x minus x1. x1 we said was -1. Ooh, now be careful here, right? Just like in our warm-up, we have two negatives, so make sure that you have x minus from the formula and then -1 from the point. So I'm going to do a little simplifying here actually, because x minus -1 is really x plus 1. So I'm going to say y minus 5 equals -3 times x plus 1. And that's it. I'm done. That's what my answer will look like when it's written in point-slope form. So that's all the equation is asking you to do. Plug the numbers into the correct spots. Slope is -3, that goes in the m spot. Point was -1, 5, x1, y1 go into those correct spots, and watch your negatives. All right, let's see if you can handle one here. It says write the equation of the line in point-slope form again. If the slope is 3/4, and it has to go through the point 3, -10. Pause your video and see if you can do this one on your own. Okay, so again, what I'm looking for is m, x1 and y1. So this time m will be 3/4, right? And my point this time is 3, -10. So here is my x1 y1. So I have y minus, y1 was negative 10, watch your negatives there, equals 3/4 parentheses x minus, this time x1 was positive 3. Now I'm going to simplify a little bit because I have two negatives right up here by the y, so I should have y plus 10 equals 3/4 times x minus 3. And that's our final answer. That's all you got to do. You don't have to do any distributing, don't have to be doing any multiplying by those fractions. You're good to go. That's it. Hopefully you did okay on that one. Just watch those negatives, right? Even if the slope is a fraction, no biggie. All right, so how about this one now? Write the equation of the line in point-slope form that goes through the points 2, 3, and 4, negative 1. So again, we're trying to find m, the slope. I notice this time it's not given, but I'm thinking we know how to do that. And then the points x1, y1 need to go in that spot. Why don't you pause your video and see if you can do this one? All right, so very similar to the warm-up, in order to solve for find m, we need to actually do some solving in this case. So m would equal the change in y. So here I'll have negative 1 minus 3, right? There's my two y values. Over, since I did negative 1 first, I have to do 4 first on the x's. 4 minus 2. All right. Negative 1 minus 3 is negative 4 up top. 4 minus 2 is positive 2 down on the bottom. Reducing that fraction, negative 4 over 2 would be negative 2 for my slope. So again, slope m equals negative 2. All right, now for point slope form, I have to have a single point x1, y1, but here I have two options. So your first option is to say, all right, let's call 2, 3 x1 and y1. In that case, I would have y minus 3 equals negative 2 parentheses x minus x1 is positive 2. y1 was positive 3. That has to go by the y. Just be careful, it's in a different order. So this would be an example of this line written in point slope form. However, you had another possibility. This is also a point on the line. So that I could have called x1 and y1 if I wanted to. In that case, I would have had y minus y1, which was negative 1, equals negative 2 parentheses x minus x1, which was 4. Now in this one, I need a little bit of simplifying. Two negatives here make a positive, so this could be y plus 1 equals negative 2 times x minus 4. Now notice, this is also a good possibility. There are two different good possibilities for equations for the same line because those are two different points that all lie on the same line. How many possibilities are there actually for any line? There's actually an infinite number of possibilities, right? Because there's an infinite number of points on the line. So it makes it a little bit harder to check your answers. But as long as you're lining up, you're putting the y's with the y's, the x's with the x's, and watching those negatives, your answer is most likely correct. So just know that there is more than one good answer for any of these equations when they're written in point-slope form. Okay. What if we have to write the equation of the line in point-slope form from a graph? So again, I'm trying to find m, the slope, and I'm trying to find a point, x1 and y1. So, and that x1 and y1 can be any point that's on the line. Well, let's start with the slope, right? Do you remember how to find slope from a graph? Rise over run. So if I start on this point here and I go to this point here, I'm going to rise negative 1. And I'm going to run 1, 2, 3, 4. So my slope would be negative 1/4, right? Now I know some of you say, well, what if I go over the top? So I'm running 1, 2, 3, 4, and I'm rising -1. That's the same thing, right? You could also, just a review of your slope, right? You could also say, well, I started here and I ran, or I went rise of +1 and I ran 1, 2, 3, -4. It's okay. It's all still slope of -1/4, right? You're good to go. All right. So I have my slope. Now I need my point. You have multiple possibilities here. Yeah, you could go with your y-intercept since you're used to looking for that. But what are the coordinates of the y-intercept? The coordinates of the y-intercept would be 0, 4. In that case, your equation would be y minus y1 is 4 equals -1/4 parentheses x minus 0. Oh, geez, sorry. There we go. So this is the correct way to write that equation in point-slope form if the point that you picked was, in fact, the y-intercept. Now, notice a lot of times you're like, Miss Grievo, I don't always have to write the -0 part. You're right, you don't, and maybe you don't have to here, but really if we're looking for point-slope form, we're really trying to pull out that x1 and y1, so we would probably leave the 0 in. Okay, so that's if you're looking for that y-intercept, but remember, you don't have to have the y-intercept in order to write an equation in point-slope form. It can be any point on the line. So let's say you pick this point, so your x1 and y1 could be 4, 3, in which case your equation would be y minus y1 here is 3 equals m is -1/4 parentheses x minus 4 would be x1. And this is also a correct equation for that line. Now you could say, okay, those are the 2 points that were kind of shown on the graph, but I could find another point. Let's say I want to have the point be this guy over here. That crosses, right? If I count the slope, that's -1/4. Sure. All right. Well, in that case, then your equation would, or your point would be -4, 5. So your equation would say y minus 5 equals -1/4 parentheses x minus -4. Watch your negatives on this one, though. 2 negatives here turn it to a positive. Whoops. Okay, so really this would be y minus 5 equals -1/4 parentheses x plus 4. But that's also a good possibility as an equation for this line. So again, an infinite number of possibilities. It all just depends on which point you choose to write your equation with. All right, let's see. Why don't you guys go ahead and try this equation, write it in point-slope form. Find the slope, pick a point, write the equation. Pause your video. Okay, so if I'm finding the slope on this one, I'm going to say I'm going to start with this point, end at that point. Sorry about the honking out there. I'm going to rise 1, 2, 3, run of 1. Sorry guys, it got a little noisy here all of a sudden. So rise of 3, run of 1. My slope would be 3/1 or just plain old 3. Okay, now if I pick a point, notice my y-intercept isn't even shown on this graph. So I can't even use the y-intercept necessarily in order to write my point. And that's okay, I don't need it here. Now if I had to write in slope-intercept form, it would take me a lot longer to do this problem. I'd have to figure out what that was and go from there. So this is a time saver. Let's say I choose this point. That would be 2, -2. And so then my equation would be y minus y1 is negative 2, what's your negatives, equals m, which is 3, parentheses, x minus x1, which is positive 2. Got to do a little simplifying. Y minus a negative there gives me a positive. So it's really y plus 2 equals 3 parentheses x minus 2. So that's one good possibility there for your equation. But you didn't have to do that point. You could have picked the other point. So let's say that I chose this point as my x1 and y1. In that case, my point would be 3, 1. So then my equation would be y minus y1 is 1 equals m, which is 3, parentheses, x minus x1, which is 3. No negatives to deal with on that one. That one might have been a little bit easier to choose, but you could have done any one that you wanted. And again, you could have written an equation with this point up here or this point down here. Just remember to watch those negatives and put things in the right spots. Those are all good possibilities. All right, hopefully you're getting the hang of it by now. So what if I give you the equation in point-slope form and you have to graph it? So just remember what everything stands for in your equation, right? I have y minus y1 equals m times x minus x1. So if I look at this equation, this number right here, right in front of the parentheses, that's your slope. So your slope is negative 2/3. Now you might be thinking, maybe I need to distribute that and put it into slope-intercept form in order to graph this. No, you don't. You're given everything you need, right? Remember these other two spots, y minus y1, x minus x1, that's a point. That's the point x1, y1. And I can count slope from any point that I want. It does not have to be the y-intercept in order to count the slope. So here I see y minus 3 and x plus 4. So y minus 3, y minus y1. That means 3 must be y1. Ooh, see, I almost put that in the wrong spot. Be careful. 3 is y1. Now over here, though, this says x plus 4, but it's supposed to be x minus 1. Or excuse me, x minus x1. So this should really be x minus something. Well, x minus what would give me x plus 4? It has to be x minus negative 4 so that it would turn into x plus 4, right? So be careful here. So my x1 isn't 4. My x1 is negative 4. So just watch that. Remember, the minus is part of the equation. So if the minus is in here, then it's just a regular old 3. But if it's a plus, that means it must have been a negative number to turn it into a positive. So just that's the only tricky part about this. But now let's take a look. Okay, so I know my point is negative 4, 3. Negative 4, 3 would be right here. And now I can count my slope from there. Rise of negative 2. Run of 3. Here's the next point. Rise of negative 2, run of 3. And so on, right? And then I can draw my line. And hopefully yours is much straighter than mine is. A little bit hard to do that straight line on my device here. So you can graph straight from point slope form because it's giving you a point and it's giving you the slope, and you can count slope from any point that you want. It doesn't have to be the y-intercept. And changing that into slope-intercept form, take a look at where that y-intercept would be. Ugh, I don't even know where that point is. That would be a nightmare. So graphing from point slope form sometimes is even easier. So just remember, you do not have to convert out of point slope form in order to graph it. All right, we've done everything there is to do with point slope form. Just remember when you're writing those equations, watch your negatives, right? And there are many possibilities for correct equations if you're writing in point slope form because you can pick any point on the line. The slope will always be the same though, so make sure you check that. And then whenever you're graphing a line in point slope form, you can start counting slope from any point you want. It doesn't have to be the y-intercept, so you do not need to convert out of point slope form in order to graph. All right, so here's a link to your homework worksheet for today for point slope form. And if you need some extra practice, make sure that you are asking your teachers.